Welcome. This video is CCBYNC. All right, we are to the last chapter in trigonometry where we're going to be talking about polar coordinates and polar equations. And I've made this into one lesson, even though it's in your book, it's broken up into three sections. Polar coordinates are a different way to get to a point. What we're used to is our Cartesian plane, where we start at the origin and we go in the x direction and then in the y direction to get there, to the point here, x comma y. And these are called rectangular coordinates, and you can see they definitely make a rectangle, which is why they're called that. They're also called Cartesian coordinates, named after René Descartes, who was a great mathematician. All right, now what we're doing is we are saying, hey, instead of going the traditional x, y, what if we go from the pole straight to the point and acknowledge the angle and how far away it is? So in other words, we're going to go an angle and then how far from the pole are we going? So here we have the polar axis and the pole, which we call the origin. And you can see we go counterclockwise. That's always a positive orientation when we're looking at a thing. And when we are no longer using Cartesian coordinates, our point now is r comma theta. So that's a new ordered pair for us. And r comma theta can get us to the same point that x comma y can as well. And we'll talk about how to translate between the two in a little bit. So again, turn the angle and then how far do you go? And that distance that you go, we call r, or the radius. Now, the interesting thing is that there's many ways to represent the same point in polar coordinates. Unlike Cartesian coordinates, where we have, how far from the x, from the pole, from the origin do we go, and how far in the y direction do we go from there. So there are four ways, and we have our first polar coordinate. The radius is 2, so from the pole, wherever theta takes us, we're going to go out to 2. In this case, theta is going to pi over 4, so 45 degrees. And we turn 45 degrees, we go out 2, and we get to that point. Now, another way to get there is, what if we go all the way around once and then go to pi over 4? That's 9 pi over 4. And then we go a distance of 2. Do you see that's getting us to the exact same position? Another way to do this would be to go backwards. So if we go clockwise, which is at the negative angle, we go negative 7 pi over 4. And then from there, we go out a distance of 2, a radius of 2. Now we can even have a negative radius, which it sounds kind of weird, but what we could do is we could go a positive 5 pi over 4. So view it this way. This is the positive direction. So I'm turning all the way to 5 pi over 4, but now I'm going backwards. So I'm kind of going in the opposite direction. But it still gets us to the same point. And by the way, we could also have a negative angle, negative 3 pi over 4. You can even write that out. Another one would be a negative to negative 3 pi over 4. And that would be going to here, which is negative 3 pi over 4. And then going backwards 2. So there's actually 5 representations here, because this one we went all the way around. So you can imagine you go around twice and then go as well. All right, example 1. Suppose a point has polar coordinates negative 4, negative pi over 2. Find 2 additional polar representations for the same point, where theta is between negative pi over 2 and 2 pi and positive 2 pi. First, let's find this point. It says to start here, and we're going to go a negative pi over 2 and then go backwards 4. So I'm going to be up here. So 1, 2, 3, 4. There's my point. So that is the point negative 4, negative pi over 2. And now I need to find new ways to get there. Well, one thing I could do a negative, let's use a different color. I could start here and I could go a negative 3 pi over 4, and then a positive 4. So that would give us the point negative 3 pi over 4, 2, pardon me, negative 3 pi over 2. We need r first, of course. So 4 comma negative 3 pi over 2. There's 1 point. Of course, another way to get there is to go positive 4 and just go pi over 2. Right? That's from here to there. And we could find others. But you can see it's not particularly difficult. You just have to kind of open up your mind a little. All right, let's try another one. All right, suppose a point has a polar coordinate 6 comma negative 5 pi over 3. Find 2 additional polar representations of the point. Well, let's find this point. Negative 5 pi over 3. That's this way, this way, this way, this way, all the way to here, and then a positive 6. So I'm going to go a distance of 1, 2, 3, 4, 5, 6. I'm going to recount that. 1, 2, 3, 4, 5, 6. There we are. 6 negative 5 pi over 3. That's from here to here. Negative 5 pi over 3. All right. Well, it's looking to me like we could go a positive pi over 3 and go out 6. So positive pi over 3, so we're going to go out 6 and a positive pi over 3. So that's the positive r and a positive theta. We can also go a positive four pi over 3. But I'm going to go negative 6. I'm going backwards. So I'm going all the way to here. So I'm facing that way, and then I'm going to go backwards 6 to get to my point. A little crazy, I know. All right, so we're going to identify the coordinates of this point. Let's mark it up a little bit brighter. This point here. And for part A, they say they want a positive radius. In other words, I'm here, I'm going to go straight to it. I'm not going to go backwards. And a positive theta. All right, so let's see. These are broken up into pi over 6s. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. 7 pi over 6. And what is our radius? 1, 2, 3, 4. So part A, where r is positive and theta is also positive, we're good there. So we went this way. Now, let's do part B. Let's kind of do this. We went to there, which is a positive 7 pi over 6. Yes. 7 pi over 6. We want to get to that same place, but now we want a negative radius. So I'm going to keep this nice and simple. I'm going to go to here, which is pi over 6. But now r is negative, so now I have to go negative 4 to get there. In other words, I'm turning here, and I'm going backwards 4 to get to the same point. This is part B. All right, we are to conversions. Polar Cartesian conversions. So here we have our classic, here's our x comma y, or theta, and then the r, but we put r comma theta. And we can, let me mark it up a little bit more clear. This is r, this is x, this is y, and this is theta. And we can see, we definitely have some connections here with our conversions. We can see that the cosine of theta is x over r, which means x equals r cosine theta. So if we have r and theta, we can get our x value. We'll also have that sine of theta is y over r, or that y is r sine theta. So these are the big ones here. Now we can go the other way. So in other words, if I'm given r and theta, I can get x and y coordinates from that, just the conversion factor. Now we also have, first of all, x squared plus y squared equals r squared. There's a Pythagorean theorem, of course. So if we have x and y, how do we get r? Well, we do this. And you can see r could be plus or minus, right? Negative or positive. I can also make the connection that the tangent of theta is y over x. We've seen this before. This is not new. However, this is how we would find our theta. I want to caution us with this one. We really have to know what quadrant theta is in, because as you know, when we do inverse tangent, it either throws it as a negative angle into quadrant 4 or a positive angle into quadrant 1. So if the angle needs to be between 0 and 2 pi, the negative angle won't work. And if it's in quadrants 2 and 3, we're going to have to make some adjustments. All right, so let's do this. Convert Cartesian coordinates. So this is x comma y. So x comma y is what we have, and we want to go to r comma theta. All right, so part A, we have the point 2 root 3 and negative 2. Now I want to point out we are in quadrant 4 in this case. They specifically want the angle to be between 0 and 2 pi. Let's start with r. So I'm going to use my formula up here. So r squared equals x squared. So 2 root 3 squared plus y squared, negative 2 squared. R squared equals 4 times 3 plus 4. That's 12 plus 4 equals 16, which means r equals 4. Okay, no problem. Now the tangent of theta is going to be y, negative 2 over 2 root 3. Tangent of theta is negative 1 over root 3, or root 3 over 3. Now I want to point out on our unit circle, inverse tangent is going to give us, so here we are here. It's going to give us a negative pi over 6, or a negative 30 degrees, depending on what mode your calculator is in. However, we need our angle between 0 and 2 pi. So I can look and see that we are at 11 pi over 6, meaning if I start here and go all the way around in the positive direction to here, I stop at 11 pi over 6. So this means that theta is going to equal 11 pi over 6. So this converts to r, which was 4, and 11 pi over 6. Now you might be asking yourself, why did I make r positive as well as theta? Well, theta has to be positive because of here. And in general, if we can keep r positive, there's some advantages to that. All right, let's do part B. So we have the point, and this one's not going to be as nice, meaning we're not going to get something on the unit circle, most likely for this one. All right, so we have the point 1, 5. Now the good news is we're already in quadrant 1, so we don't have to worry about anything getting weird with theta when we do this. So r squared equals 1 squared plus 5 squared. So r equals root 26. We can keep that exact, that's no problem. However, with the tangent of theta is going to be y over x. So that's going to be 5 over 1, or just 5. Now I have to go here. And it tells me to keep it in radians. So I need to make sure I'm in radian mode, which I am. I'm going to do inverse tangent of 5. So theta is about 1.37, we'll say. So our ordered pair is root 26, comma 1.37. Now, ideally, if we can get an exact value like we did here, that would be really nice. So here are my answers. All right. Moving on. Find the rectangular coordinates. So now we're going the other way. So now we have r and theta. So we're going to be using these formulas here. All right, here we go. So x equals r cosine theta. And so x is going to equal -4 times the cosine of pi over 3. Using our unit circle, cosine is the x coordinate, pi over 3. It's going to be 1/2. So this is -4 times 1/2, which is -2. So there's our x coordinate, or y coordinate. Y equals r sine theta. So y equals -4 times the sine pi over 3. Sine is the y coordinate at pi over 3, root 3 over 2. So what do our x comma y coordinates look like? -2 comma -2 root 3. All right. We are now to polar and Cartesian equations. So we have equations and we have conversions, and we will mostly be using these 4 here. So you'll want to have these handy as we're looking at that. And I have some graphs here if in your notes, if you wanted to see what the graphs look like, that would be perfectly fine. Let's do part A here. X squared plus y squared minus 4 equals 0. And I'm going to recall that x squared plus y squared is r squared. So the equation r equals 2. And I hope that you can see that this becomes x squared plus y squared equals 4, that this is a circle of radius 2, centered at the origin. And you can see when r is a constant, that means it's out here. It's exactly this circle right here, because r is the same for every value of theta. All right, so next up, part B. X squared plus y squared minus 2x equals 0. Well, I know that x squared plus y squared is r squared, and x is r cosine theta. We're going to assume that r is not 0. And by making that assumption, I can actually divide through by r. And what I did was I added the 2r cosine to the other side and divided the r out. And you can see r is now a function of theta. Now, to be clear, that's r is a function of theta. That's not r times theta. So this is our converted equation. Part C, let's do a different color here. Part C is x equals -1. X we know is r cosine theta equals -1. And if we can get r by itself, we do try to do that. And we're going to assume that we're going to do this when angles where cosine is not equal to 0. And as you know, 1 over cosine is secant theta. So there's our new function. And let's do a different color even yet for part D. Y equals 7x squared. Y is our sine theta. X is our cosine theta because we're squaring it. They both get squared. And once again, we're going to assume that r is not equal to 0. If r does equal 0, then 0 equals 0. Who cares? What we call the trivial case. So I'm going to divide out an r. And in fact, to get r by itself, I'm going to divide out 7 cosine squared theta. Giving us r is sine theta over 7 cosine squared theta. Now, you could, so this is fine as an answer. Some of you a little bit more ambitious might see that this is 1/7. Sine over cosine is tangent theta. Then we have another cosine, 1 over cosine, which becomes secant theta. So both of those would be equivalent answers. All right. Now we're going to go the other way. Once again, using these 4 conversion factors. I'm going to do this for part A. Theta equals 7 pi over 4. I'm going to go ahead and take the tangent of both sides. Now, on the right side, tangent is 7 pi over 4. Here's 7 pi over 4. Tangent is -1. Also, tangent is y over x. And you can see this is actually a straight line, right? It's in y-intercept form. Y equals mx plus b. So this would be at the origin with a negative slope, a -1 slope. All right, next up, see if I can squeeze b over here. Do b in black. R sine theta equals 6. Well, this is just r sine theta is y. Again, that's a horizontal line, right? At 6. Let's do C. Now C. R equals -6. I'm going to go ahead and square both sides. And r squared is x squared plus y squared. And here we have a circle centered at the origin with a radius of 6, which is exactly what that is. Now we lose the negative in there, but it doesn't matter when we're in rectangular coordinates. All right, that was C. Let's move on to D. D is r equals -4 sine theta. If we go back here, sine of theta is y over r. And I'm going to go ahead and multiply both sides by the LCD, which is r in this case. That's going to give me r squared equals -4y. And I know that r squared is x squared plus y squared equals -4y. And you could stop here. This would be an acceptable answer. I want to show you how we can go even further. And I could actually complete the square by adding a 4 to both sides there. So if I add it to this side, I have to add it to this side. This becomes x squared plus y plus 2 squared equals 4. And again, you can see it's the same as the one above. But in this case, we can see that it's a circle where the center is at 0, -2 with a radius of 2. Just a little bit more clear, I think. All right, that leaves us with purple for part E. R equals 1 over 8 cosine theta plus 3 sine theta. And I'm actually going to cross multiply here. So this gives me 8r cosine theta plus 3r sine theta equals 1. And as we know, cosine theta is x over r and sine theta is y over r. Very nicely, we can see those r's are going to reduce out. You could stop here. Your teacher may tell you to solve for y so that we can see that x is a function of y. So this is just a straight line. We could put it in slope-intercept form, but it's not necessary. This is a new way of looking at things. I know it's a little weird, but after you do enough of them, you can kind of get used to it. You really need to focus on those 4 equations for polar equations and coordinates.